Hey everyone, Brian Beeler coming to you with the Storage Review podcast, and today we've got a great conversation, or at least I expect it to be a great conversation between me and one of the grumpiest men in enterprise IT, Chris Mellor. Chris, thanks for coming in with us today.
Grumpy? I thought that was your title.
Of course, I'm teasing out of affection. But you have been known to be a little difficult on your interviewees and certain media press sessions when we're being not force-fed, but gently spoon-fed piles of malarkey in a spoon.
Good Lord, Brian. This is time for one of those pregnant pauses where I try and think of something quickly to divert you from another topic of conversation. So, what do you think about the Optane business?
Yeah, right. So you've been doing a lot of the work this week on picking up on what was a relatively small note by Micron on their plans with what they call 3D XPoint, what Intel calls Optane in the packaged marketing sense of it. But what did you stumble across, and what have you unpacked since then?
Well, I first stumbled across it due to time zone differences when a Wells Fargo analyst, Aaron Rakers, who's put me on his distribution list, sent out a note saying Micron was going to stop manufacturing 3D XPoint and was going to stop its development of 3D XPoint as well and put its Lehigh fab up for sale. It has a quarterly reporting session coming up, so it made this special announcement, and I thought this is huge. The first thing that struck me was that Micron had taken a deep look at the 3D XPoint market and said, this is not for us. We can get a better return on our investment in it 5 years after plowing away at the thing by simply getting out of the business and putting our dollars somewhere else. And it seemed to me brutal.
Well, that notion right there is so bizarre, right? Because didn't they just buy out the factories from Intel to make this stuff, 18 months ago or so?
Yeah. They bought them. They bought out Intel's share in the Intel Micron flash technologies, which was the Lehigh fab and another 3D fab someplace else, having previously separated their 3D NAND development efforts. And it almost begins to look as if this is part of a continuous thrust by Micron to get rid of the Lehigh fab. One of the analysts on a call after Micron's announcement asked why the Lehigh fab wasn't being repurposed to build 3D NAND and to help Micron in its 3D NAND manufacturing. And the Micron exec said it doesn't fit in with our expansion plans. It's more cost effective to build extra 3D NAND manufacturing at plants abroad rather than have Lehigh build 3D NAND. And that is the finances are the finances. You can't argue with that. But they made enormous protestations of amazing gratitude to the people at Lehigh for their contribution, their ingenuity, their this, that, and the other, and then basically they've thrown them to the wolves. It's an incredibly ruthless business.
Well, so it's funny. So you can't but to help to intertwine Micron and Intel through this because they've had this relationship for so long, and Intel is obviously invested heavily in Optane. They're selling the NAND business, if approved by China, presumably, to SK Hynix. That's a $9 billion sale that should theoretically close sometime later this year. It's going to be really interesting to see what happens there as the two companies further diverge, Micron and Intel, and what Intel does with that $9 billion. It's kind of hard to imagine that they plow a lot of that back into Optane, because as you've seen, and we both know from looking at stats and penetration sales, that Optane is a really neat product as an SSD. It's a neat product as this persistent memory DIMM form factor. but neither one are exactly high penetration sales units for Intel.
I think the Optane SSD has been classified as being great for storing metadata. It's got terrific endurance, so you can write metadata to it again and again and again and again, and it won't wear out, whereas a normal NAND SSD would eventually wear out. But that's a fairly niche market. Sure. And if you just want a faster SSD, then paying the Optane premium to get it, it's a heck of a price. And I think it's a niche market. I don't think it's a mass market at all. The Optane DIMM, that gives you a lot more speed. But to use it as memory, you've got to have enormously complicated software changes for applications. And that's why it's taken Intel 5 years to get a reasonable ecosystem of enterprise software manufacturers supporting Optane. There's no mass market there.
No, when that first version came out 2 summers ago, so I guess the summer before we all forgot the summer of COVID, I did a speaking engagement for Super Micro, and I was talking about the benefits of what persistent memory can do, right? And I think you're right. It's exciting in that you can drop it into existing Intel servers without having to hardware architect anything. But you really need software to take advantage of it. And the fact is that Intel got hit by negative price movement in their case, because DRAM used to be very, very expensive. And so when persistent memory came out, it was going to be well less expensive than DRAM. But that simply is not quite the case anymore. Before our call today, I checked on a local retailer here in the US, and the price delta for like a 256 gig module of PMem to DRAM is it's hundreds of dollars. It's not dramatic orders of magnitude. So even the pricing has been a little bit of a problem. And of course, like you said, you need to have an application that can take advantage of, which there are applications out there, but it's not mainstream enterprise. All the servers have PMem. It's very specific applications that can take advantage of it. And if you're that application, fantastic, huzzah to you, because it will really make a big difference. But for a lot of the rest of the world, it just hasn't happened.
I don't know about you, but I'm thinking that PCIe Gen 4 is going to make a huge difference to servers and to applications with data on SSDs. And if I'm an application and I want a large amount of data fast, well, I could use Optane and bulk out my DRAM and servers and put a lot of data in Optane, and that would give me some benefits. And there are a lot of software difficulties for that. Or I could just use normal NAND SSDs, pump a PCIe Gen 4 bus in there, and suddenly I've got vastly faster access to the SSD data. What am I going to do? What's the mainstream? I think it's going to be PCIe Gen 4 and not Optane DIMMs or Optane SSDs.
Well, you make a very good point about the SSDs. We've got Gen 4 drives in from Toshiba, Hynix, and Intel, and have tested them all. And the performance available on the Gen 4 drives is tremendous. To this point, though, the limitation has been you have to have an AMD platform. Which there's nothing wrong with that. EPYC is fantastic, and we've seen over and over again the performance profile of Gen 2 and now Gen 3 EPYC is extraordinary. So we've looked at the Gen 4 drives in Lenovo and Dell and some other platforms that support Gen 4 interface in the front, and you're right, it's fantastic. Plus now you can put 4, 8, or whatever size you want drives in these systems and get a nice big fat data footprint too. We've looked a lot at Optane, and your initial point of using them as metadata, absolutely, or a cache in something like vSAN. They actually do really well there. And the other thing with Optane SSD is that they're limited by capacity. I think they only go up to 1.5 terabytes now. So in that case, they work really well. But you're right again in that we're not seeing a whole lot of storage arrays filled. Dell does the Power Store in an all Optane version, but that's pretty niche in terms of the broad-based adoption of Optane. So I think you're right that Gen 4 is definitely the path forward.
I've got a bit of a down on Optane at the moment. I think maybe it's I'm suffering from dyspepsia or something, but I'm thinking that there's this gap in the memory storage hierarchy, and storage class memory is supposed to fill the gap between memory on the one hand and NAND SSDs on the other. And it does that because it's supposed to be faster than SSDs at an acceptable price and not as expensive as DRAM with an acceptable speed difference. It's a little bit slower than DRAM. Mm-hmm. Well, if Optane DIMMs are used to bulk out DRAM, then the people doing that don't really want to use Optane DIMMs. They want more DRAM. It's faster, but they can't afford it. And also it's capacity limited on a CPU basis because of the socket limit. So AMD have bumped socket counts up from 6 to 8. Ice Lake Xeons are going to bump it up from 6 to 8. And we've got high bandwidth memory coming along. And that gets rid of the whole CPU socket limitation by having a dedicated interposer card between the stacked HBM memory dies and the CPUs. Well, surely this is Optane's opportunity is time limited. There's PCIe 5 and faster SSDs coming along at the bottom. There's greater memory capacity with HBM memory and 8 sockets rather than 6 coming along from the top. And then longer term, there's this CXL bus. And Micron says in its announcement in the investor call that it wants to focus on the CXL bus memories and storage class memory using the CXL bus. Well, I don't know about you, but I'm thinking Optane, CXL bus interface? No. Intel doesn't want to do that. He wants to keep Optane DIMMs as a reason for buying Xeons. AMD CPUs may be faster, but stick an Optane DIMMs with a Xeon CPU and the overall speed is faster than an AMD server. Do you see that?
Maybe. I think you're absolutely right in your assertion that this is an ecosystem play. And the only way that Intel, I think, can be really successful going forward is convincing the market, hopefully through performance data or pricing or whatever, that the better together story holds true when you look at the CPUs, the persistent memory, the Optane, the whole story. And I think they're going to talk a little more solutions-oriented conversation going forward. How are they doing things to make their platforms better for AI or for security or for whatever it is, and really talk features, talk solutions, and talk less cores and gigahertz. I will say the one thing though about persistent memory that's interesting. I'm sure you know the MemVerge guys. We've been working with them on a couple different things, and we're going to hit them again on the new Ice Lake systems and the 200 series PMem, because they've got one of the few really good value propositions to be able to take advantage of the persistent memory and the other layers in the pyramid of storage, right? And one of the biggest things that they tell us that their customers are excited about, and by the way, they're working on some stuff for media and entertainment too, which is super cool, but it's the ability to rehydrate or not have to rehydrate the whole RAM footprint, that the persistent memory, that whatever your working set, if you have to restart the system or it locks up or whatever, that's all there. And if you don't have to refill 4, 5, or 6 terabytes of DRAM, even though that's fast, it still takes time, that there's some benefit there. But it's still very specific in the use case.
I figured that's really impressive technology. And they also seem to have built a sort of software abstraction layer so that applications using their in-memory technology don't have to take account of whether they're writing data to DRAM or to Optane. The MemVerge software takes care of that for them, which is great if you're into in-memory technology. But if you're not, then you don't need it. So I think Intel will love MemVerge to death. But long term, I don't think it'll do much good. I think Optane has to have some kind of mass market adoption, so that it becomes a more or less standard aspect of servers. And until that happens, Intel are in trouble.
Well, it's interesting because we've talked about this before. I mean, you brought up the pyramid, and if people don't know, Intel loves this data pyramid where it starts with the memory at the top and then goes down all these layers as your data gets colder and colder and colder and larger and larger and larger, where they like to insert Optane, persistent memory, and even once upon a time when the pyramid was much shorter, the SSDs that went in there ahead of the hard drives. All these complexities or opportunities, I suppose, to take advantage of the different architectures open a lot of doors for the software-defined guys like MemVerge, like vSAN to a certain extent, Store One. I mean, there's a lot out there that's really pretty compelling. It does, though, remain to be seen. Even Microsoft on their some of their HCI work around Hyper-V. It just remains to be seen. To your point, I think, how much does the market care about the technology, and how much do they care about the results of whatever it is operation that they're trying to achieve? And that's something that we get hung up on all the time. Is as technologists, we get sometimes too far down in the weeds on how does this thing work or why does it work, and not what's the end result out the other side. If I'm running SQL Server or whatever, and I can do these jobs faster, there's a business benefit there. What's underlying, I don't really care, do I?
You're making good points. You aren't making
surprising.
I'm going to step off to one side a moment and say that for Optane to be seen as a crutch for an inferior CPU line is not a good perception of Optane.
Wait, did I say that or did you say that?
No, it's a crutch, isn't it? It's a crutch to keep slower Xeons in the market and stop people buying AMD CPUs. If Intel had decided to make Optane open, publish the interface, and let AMD CPUs work at it as well, or let ARM CPUs work at it as well, the overall market possibilities would have expanded hugely. But it decided not to do that. It decided this is our technology. We want to keep everything to ourselves. And we somehow managed to persuade Micron for 5 years not to make its own Optane products for users, not to make its own Optane SSDs, not to make its own Optane DIMMs and sell them. And it's a nonsense, isn't it? It's a classic example of an incumbent seeing a new technology and using it to defend their existing base of products rather than striking out with strength and vigor for new markets, come what may. Don't you find that view's got some point to it?
Yeah, oh, absolutely. But they've done this before. If you go way back to the beginning of Flash with their X25M Intels, that was one of the first really good mass market SSDs. I mean, they did the deal with HGST back then and said, you know, HGST, you can go have, in this collaboration, you can go have the SAS market, which was de facto enterprise standard at that point, and we'll do SATA, and whatever happens in the future, we'll figure out later. And Intel astutely saw NVMe coming and then hopped the whole SAS interface, and they've had a tremendous product line since then. Yeah, I mean, I think you're right about the assertion of Optane, whether it's SSD or persistent memory, that they need that solution portfolio to really have a nice bundled advantage in the server space. I'm not sure that there's any other way around it.
Yeah, if I'm a big enterprise software vendor, and I've managed to change my software and adapt so that I can now use Optane and get benefits from it, it's still quite a difficult pitch to put across. I rarely see a paper, say, from some enterprise software vendor saying that run my software in servers with Optane DIMMs and it'll give you a 50% price performance advantage. It never seems to be put in those simple terms. It seems to be that your average number of queries per hour that are colored blue on a Wednesday will run much quicker than they do on a Thursday. It's all complicated. There's no simple black and whites with Optane, and that seems to me to be a missing part of the appeal somehow. SSDs are simple, aren't they? They're either faster, or they hold more, or they're cheaper. It's relatively straightforward, but an Optane DIMM-assisted piece of software, it's never that simple.
Yeah, well, it's interesting because we talked about Micron investing in the space and then walking away from it. They even went so far to announce the X100, their next generation Optane killer, right? And so they've thrown that away. But
from zero to zero in months.
Yeah, but Micron's got this history with, I don't know what it is that some new SVP comes in and reimagines Micron. And Micron fundamentally for decades has been a silicon manufacturer, and they're really, really good at that. And when they try to go outside of that zone, that's when they have trouble. I mean, I remember maybe you were at some of these events in the U.S. They launched a tech center down in Austin 5 or 6 years ago because they felt like that's where the cool kids were and they needed to be there, and Boise wasn't cool, which turns around, Boise does tend to be cool. But anyway, then they had an event at One World Trade Center in Manhattan 3 or 4 years ago where they launched a Micron storage array. To turn out it was just, I think it was an Accelero array or whatever. And I said to the guys, how are you going to service and support a storage array? That's not your DNA. It's not what you do. It's a totally different mechanic that Dell and HPE and Pure Storage and others have figured out. And they said, well, we're Micron. We're big. We can do whatever we want, was the gist of the response. And I said, so anyway, that array doesn't exist. And even their current drives, we happen to have this guy sitting here, the 9300. It's a nice little drive, but it's based on technology from Memblaze. Micron doesn't do much for this. They buy the Memblaze drive. So I do wonder, looking at their history of innovation, it's been on the wafers, it's not been on the packaged goods. For many years, you'd have to go back to the P320 or P400, some of the first edge cards they made years ago, to find something where their engineering really was the forefront. So from that perspective, I see some of what you say about the backing off of 3D XPoint. It makes perfect sense because they're not well positioned to take that to market. So if that's the case, then why make it at a loss?
Yeah, I think you're making a really great point there. The whole Micron storage array business, by importing a Top Gun manager from Dell, was a fiasco. Buying the Elpida and getting into the DRAM memory business, that fitted the Micron DNA perfectly, I think. We're going to make chips. We're going to make vanishingly small chips at high capacity, and we're going to make millions of them. And they've done it extraordinarily well. XPoint, they couldn't make millions of chips. The Lehigh fab has been underutilized for years, and possibly that's it. They never saw a future where they could make millions of XPoint chips. So they want to make millions of NAND chips, and they want to make millions of DRAM chips, and nothing else. Thank you very much. We'll go away.
There's no shame in that, though, right? I mean, that's the business that they're great at. And Hynix has been really great at that, and Samsung has been really great at that, although Samsung's done a little better on the packaged products lately. But the fabs typically haven't fancied themselves array vendors. And even on the hard drive side, WD and Seagate have had smattering of success in becoming competitive with the companies they supply. With WD bought Tagile and Amplidata, and now they've spun those out, and Seagate's trying a little bit with this cloud live drive thing. But we'll see. The mechanics of going to market with an array or with a packaged solution are totally different than cranking out wafers all day long.
I think that I was wondering what word you were going to use there. There's this little delicate pause before the choice of the word smattering. And I was thinking he's going to say mixed.
So
It's a natural act, isn't it, for
Yes.
a hundreds of thousands of units a year component manufacturer to start putting out arrays that have those packages inside them. Good luck to them.
So, I mean, you've looked at this situation with Micron, with this investment in new communication technology for next generation drives. This was it CXL? Is that what it's called?
Yeah, the Compute Express Link. It's supposed to be an industry standard bus or interconnect to link CPUs, GPUs, and other accelerators to a shared pool of coherent memory. So it's a little bit like enabling something like HP's old memory machine idea, a memory-centric system with CPUs and GPUs hung off it and sharing the memory. So data in the memory doesn't have to be moved from CPU system to GPU system. And it's this fascinating idea that you could actually compose memory. You could have a composed server and give it a slug of memory from this pool. When it's finished, return the memory to the pool and have it used by somebody else. Well, if you've got a vast amount of memory, you're not limited by CPU socket concerns anymore. And the CPUs could be AMD ones, they could be Intel, they could be ARM, they could be RISC-V. Who cares? As long as they've got a CXL interface, they have access to the data in the CXL pool. If Intel were to add a CXL interface to Optane, well, that might change things around a lot.
Certainly broaden the horizons, right?
Yeah, it would expose Optane to competition, though. So far, the competition for Optane has been a smattering, I think I'll use your word there, with Samsung ZSSD, faster little thing from Toshiba and so on, the MRAM from Everspin, spin transfer torque, which is always on the cusp of about to become great. We've only got to solve this particular problem, but next year we've only got to solve this other problem, and so it goes on. So I can't see MRAM ever becoming mass market technology either, which gets me back to my little downer about storage class memory in general, as in there is no real market for it. I think I have a feeling the future is going to be CXL to shared memory, and the memory will be using this high bandwidth memory technology. PCIe buses involved in there as well, and bingo, we have a whale of a time with much faster systems in the future. I really, I'm not grumpy, I promise, I'm not grumpy. It's sad, it's wonderful technology, but it's going nowhere. It's got no long term.
Yeah, so I introduce you as the grumpy guy, and now what are you doing? You're being the grumpy guy.
Yeah, I'm living up to my billing. Oh, thank you. You're not going to get grumpy now.
You went through a list of technologies, and I mean the NVDIMM's been around for a while. It's been funny though. I'm sure you remember this. Some of the original battery backup NVDIMMs, where you would see these server chassis with these DIMMs in there, and then they're connected to lithium-ion batteries that are tucked away in the side of the chassis. I mean, they've tried all these different ways to get at what you're talking about, and you listed several of the companies involved in it. Gosh, maybe the closest would be Toshiba's, their XL Flash. We've seen that. We've seen that in OneDrive from Dapu Store. So Kioxia, Kioxia hasn't brought that to market themselves, even in an SSD form factor. So yeah, I mean the question's got to be, if they've got the technology on the NAND, and it's really pretty good, because the Dapu Store drive we saw was higher latency than Optane, but had a further right hand side for IOPS and throughput. You'd think we'd see a little more competition there.
I think so. I think Intel with Optane focused an extraordinary amount of effort into getting enterprise software vendors on board. Christy Mann and her team there in Rob Crook's organization have been working away like lazies for years trying to get this on board. But I'm just a hack. I'm not an engineer. But I just wonder if Intel had devoted an awful lot of software effort to somehow making some kind of abstraction layer, as Memburge had done, to hide the difference between DRAM and Optane DIMMs, so that upstream software didn't have to change so much. Then they could have had massive. Well, again, it's too easy for me sitting here in my little office to say they could have had mass adoption. They surely would have had greater adoption of Optane amongst the enterprise software vendors, rather than you going to a software vendor at the moment and saying, oh, so tell me, does your product support Optane DIMMs? Yeah, but you have to have version 3.021a with this enterprise. It's all so complicated. It would be faster if the enterprise vendors could just say, yes.
No, you're right. And for some of those software use cases, SAP HANA, Aerospike, Intel likes to talk about, there are a couple spots where it's pretty easy, or it's not easy, but the business benefit is real, and so those guys will make the extra effort required. But what you're talking about, I think, is absolutely right. If you look back at all the disruptive storage technologies over time, Fusion IO is a great example of this. They had this edge card with an FPGA that was the fastest thing known to storage at the time. But the dream was always that they could go to Microsoft and SQL Server and say, hey, SQL Server, now that you know you've got this flash layer available in the server and you don't have to just wait on hard drives, we can integrate through APIs or some software calls or whatever, and you can make your application flash aware, right? And when you know that we're sitting here, you can do things differently and more optimized and faster. And it sounds intuitive, right? Just like, why can't you just do that? But it's not that easy, and it never happened, or not on any sort of broad scale. A couple niche applications integrated, and that's great. But yeah, to your point, if Microsoft said, in Windows Server, we now see this just as RAM, and just sort of obfuscate the layer and just give it to you as a piece, or if Red Hat or whatever did that would be something that, as long as it adds value to these applications, that would be almost magical if it could go down that way.
Yeah, I think Intel's done this before with its rapid storage technology.
Yeah, the RST, right.
Which twins a fast cache with slow NAND and does tiering. Well, it's a pity there wasn't, as it were, a rapid storage technology equivalent for DRAM and Optane. Maybe it was because Intel was not a DRAM manufacturer. I don't know. It's a puzzle. Maybe.
Yeah, well, Intel squeezed together some pieces before. On the client side of the world, they had this H10 drive, which combined a little bit of Optane with a little bit of slow, less expensive NAND. And we've seen how many instances of hybrid drives have we seen, from hard drives with a little bit of NAND on them. WD made those. I think Seagate did one too. I mean, that was all the rage 6-7 years ago. And then we had hybrid caching software and Velo. I mean, there was a half a dozen acquisitions in that space, way back when too, as people were trying to figure it out. But it feels like we're coming all the way around again on this, where we want to use these real fast mediums as caches for now QLC drives, or slow SMR or Hammer or MAMR or whatever hard drives, or even object storage in the cloud. And we're still always talking about caching, data movement, data placement. I mean, these conversations are not new. They've been going on since the beginning of data storage, I think.
I think with Intel's rapid storage technology, it twinned Optane cache with NAND. So it was looking from Optane down the memory storage hierarchy to NAND. If only rapid storage technology could have also had a version of itself which looked up the memory storage hierarchy to DRAM, and managed somehow to combine DRAM and Optane together. But it never happened, and now it possibly won't ever happen either. I'm not an engineer. These things must be tremendously difficult to do. surely somebody in Intel thought, "Ooh, let's turn RST around and have it work the other way."
Right.
But no.
Yeah, and I don't think like all these things that seem intuitively like they could be easy answers. It's only going to get more difficult because, as you know, NVIDIA and AMD are investing heavily in GPU. NVIDIA with the Mellanox acquisition, investing heavily in these smart NICs with the Bluefield technology, the potential ARM acquisition from those guys. I mean, why couldn't they make little ARM-based servers with NAND and GPU and all this stuff, storage all on the NIC, all in one unit? You got Xilinx going after the smart NIC space that they're rolling into AMD. The dynamics of data center design, I feel like we're just right on the edge of almost a reset of how we do this, how we do composable infrastructure. To your point a little bit before about NAND, all this stuff could be turned on its head in terms of the way that it's consumed in the enterprise. VMware is even investing so much in not just containers, but the way hardware is virtualized, vGPUs and all this sort of thing. Do we end up with servers that have a little bit of everything, or do we end up with blocks of stuff, whether it's blocks of JBOFs or JBODs that are high-speed connected back into the servers that need them? I mean, there's just so much out there, and I know, we didn't even envision going down that road, but just listening to you talk about, wouldn't it be easier if, but maybe we need to shake the whole thing up again and recast the data center.
Blocks of stuff. Yeah, you can look back and you can think to yourself, well, it was so easy in those days. There was an x86 CPU, there was DRAM, and there were drives, SSDs or disk drives or tape drives, and that was it. That was your commodity hardware platform. And the application vendors came along and pointed their software at parts of this hardware spectrum, this hardware commodity spectrum, and away we went. Mass market for the application providers, mass market for the hardware component providers too. But not anymore. Blocks of stuff. The GPUs were possibly the first real hole in that dike. I suppose TCP/IP offload cards, the TONICs, were a kind of harbinger of that, but they were a niche thing anyway. But we've got GPU blocks, we've got smart NICs, we've got data processing unit processors from Sandu and Fungible. And then the composable systems thing, you don't need to know if you're an application vendor anymore. You don't need to know about the specific blocks. You just go to a liquid software abstraction layer, or drive scale as it used to be, and compose a system, and they take care of all the odds and sods inside there, like FPGAs, Optane pools, DRAM pools, and so on. Maybe the commodity hardware message is going to get diluted. We're going to have an abstraction layer over commodity blocks of hardware, but different blocks of hardware. It's going to be a different world in a few years' time.
Well, Liquid you brought up, they're doing it. I mean, they started out with this. I've got one sitting around here, the Honey Badger card that has 8 SSDs on it, and it's really cool because it takes a little PCIe switch and manages the lanes and does all this work. And that's like their party trick. That's what that's what they show off in the bar. But when you go in the back room, then they show you the virtualized GPUs and all the other stuff they're doing. They've got the right people there to make that work. Whether or not they do, I don't know, but they definitely have some players in the space with great experience, and I think that's a thing. Because why GPUs too? How expensive are those? If you're going to fill up a server with 4 or 6 or 8, depending on the server and the size of the GPUs, if you're not turning that server all day long and deriving value from those and lining up your workloads and operating more like a research university or an HPC deployment than an enterprise. I mean, it's a whole different model. And we've talked about this before. I mean, NVIDIA said years ago, well, what you could do then is have your GPU servers run analytics overnight and then have them run VDI during the day or whatever. And that's neat. That's a better way to get at the utilization. And orgs definitely were doing that, but that's not the be all end all for these really expensive accelerator cards. But yeah, Liquid's very, very cool. I was happy to get out and travel a little bit a couple weeks ago and visit with them, which is a novel idea, I know. I'm sure you'll make it back to the States sometime in the not too distant future.
No, I'm going to sit here in grumpy isolation and moan. Liquid's a fascinating company. There are a whole bunch of composable systems vendors. Dell with its MX7000, there was Drive Scale, Liquid, and Western Digital's even got a open flex composable system. But Liquid's managed to get some momentum going in the high performance computing space. They knocked off 3 or 4 supercomputers installations using their Liquid composability software. They're making progress there. And I think they're going to find a way into the enterprise on the back of their HPC experience.
I agree entirely.
If I was shares, I'd buy shares in Liquid.
Yeah, can't yet, I don't think. But they've been really smart in their go-to-market. They're quietly winning government contracts. They're winning some HPC deals, as you say, some education deals, and they're partnering with the big Dell and HP and whoever, Cray, and that makes a lot of sense. And they're not doing it with a lot of fanfare and celebration, even though they've got a couple people involved that were with Fusion IO, for instance, who was all about fanfare and celebration. But this is very much workmanlike business of knocking out contracts and doing deployments and installs and then moving on to the next one. Very methodical. But I do think they have something. I'm certain of it, in fact.
Okay, one other little point. You mentioned GPUs. Several of the GPU vendors are using high bandwidth memory in their GPU systems. So the idea of having high bandwidth memory connected to a CXL interconnect with CPUs the other side of that, it suddenly becomes a very powerful idea. Great pools of memory, CXL interconnects to them, a whole series of different kind of processors around the edge, and then a composable systems angle to it as well. I can't find the space for Optane in this.
Yeah. You're back on beating up on the poor persistent memory. All right, so look in your crystal ball then, knowing what you know, you've done all this research and reporting, you've talked to analysts on what this means for Micron, what it means for Intel, and I'm not real worried about Intel. They'll go figure it out. If they have to rebuy their fab or move their production down to Arizona or whatever, they'll figure it out. They're big boys. I'm not worried about them. But from a Micron perspective, where are we in 3 years? Are they shipping product with this thing?
I found this really intriguing. The investor call after their announcement about their XPoint withdrawal said they were committed to taking their XPoint learnings, their wonderful technology developers from XPoint, and developing new storage class memories with a CXL bus focus. But they're selling the Lehigh fab, so they don't need to build these memories now. So I wonder whether they actually have them, whether they're actually real projects or whether they're research and development dreams that saying, for instance, we could take the phase control storage bit of XPoint and use it in some kind of different structure that gives us byte addressability but without the XPoint capacity limitations. I think these are they're a long way off. We're talking years away. Who knows what's going to happen in the meantime? And I wouldn't bet on Micron ever introducing a storage class memory technology of its own. It can make hay while the sun shines out of NAND and DRAM. What does it need storage class memory for? This has been a puzzle to me, Brian. When Micron started introducing or started talking about its Quantex devices, I thought anybody who buys a Quantex device probably is not buying an SSD, and is buying less DRAM than they would have done before. How does that benefit Micron? I couldn't see it. Maybe you run a spreadsheet and you say overall Micron's business expands because its customers spend more money with it. But I'm a simpleton. I couldn't see it. I can't see the black and white appeal of storage class memory to Micron at all.
I think you're selling yourself a touch short. But what we said at the very beginning is Micron's really good at cranking out lots of big, round, shiny wafers, and clearly the Optane wafers the volume isn't there. I mean, it's just math, right? And so it makes sense that they would stop. But to your point, I don't know. I don't know what 3 years looks like. I don't know. I'm sure Micron can produce the wafers or whatever the next gen technologies are. No question about that. For me, I'm left with thinking we may be just content to keep seeing them crank out these SSDs that they make in partnership with others. Seagate before Memblaze, they had that relationship, and so that's fine. But kind of be who you are and not try to be something else with this shiny halo product of 3D XPoint. And I think this is a little embarrassing for Micron in the end of announcing the product, which was a mistake, but clearly driven by someone in marketing, which most mistakes are, to be fair. But I'm sure they had engineering just shaking their heads and saying, please don't do this, because someone always knows in the works. Someone always knows that whatever marketing is saying, how legitimate that is. And this one they had to know that X100 was never going to make it.
That's an interesting angle you mentioned there, because I had a chat with an anonymous storage industry insider who's reasonably well placed to know things. And he or she suggested that Micron couldn't actually build a controller properly for the X100. That a normal NAND controller wouldn't work because, of course, it wasn't dealing with flash, it was dealing with XPoint. Mm-hmm. And the controller difficulty was so great, the engineers basically said, we can't build it. So that's possibly what happened. The marketeers thought the X100 was a great device, the fastest SSD on the planet sort of thing. And then there was a knock on the door a few days later, and the engineers said, you do know
we can't make it. Look, that conversation happens all the time in technology. I wouldn't be surprised if that's what happened here. And again, just be who you are, and that's okay. I mean, so you don't need a big shiny SSD halo to go to market with. And yeah, it's unfortunate. I'm sure people have been disadvantaged because of decisions made by others above them. And what are you going to do? That's kind of how life works. So put it on the table. Will we see a Micron next-gen memory on the CXL in a packaged Micron solution in the next 3 years?
I think we will. I'll leave you with a Jim Handy thought, Mr. Objective Analysis, who said that Intel has always managed to develop some memory and then sell it. Mm-hmm. So it was in the DRAM business for a while, but it sold it. It's been in the NAND business for a long time, but it's selling it. Mm-hmm. And now it's in the Optane business, and it's having partnership difficulties. So maybe it's going to end up selling that as well, because its business is CPUs, it's processors of one sort or another, not memory.
Well, that may be true, because they've got this $9 billion coming in. They'll be able to reinvest that and deploy that war chest as they like. It's interesting. I mean, you're watching the CPU battles as we are between Intel and AMD, and there's no hotter time than right now to be involved in it and watching the battle. We'll see. We should regroup on this in a little while and see how this all plays out.
Thursday, okay?
Chris, I thought we were going to talk for 20 minutes about Micron and Intel splitting and the future of Optane. But this has been a fantastic conversation. Appreciate you doing it, and we'll definitely do this again soon.
It's a pleasure, Brian. In these days of not being able to travel, putting a vocal hand across the water like this is wonderful. So thank you very, very much, and enjoy the rest of your day.
Thank you. See you.